All right. So today we're going to be talking about exponents. And exponents are really interesting, okay? First and foremost, something I want to talk about is what each of these terms actually are when it comes to an exponent. The actual exponent itself is going to be the 4 that is raised above the x here. What you're going to see happen is you're going to see people call stuff a base, and the base is going to be what goes underneath the exponent. In this case, the x is the base. And then the last thing we want to talk about is the coefficient. This is going to be the number that goes in front of the x. Each of these things represents something completely different, where the exponent and the 4 go together. X is the base, not 3, just the x. And then the coefficient is going to be the 3 that's in front, not the x. So whenever we're talking about like a constant, that is going to be what we would call our coefficients, okay? So you are going to want to make sure you have those at least labeled. Now, some people do struggle when it comes to exponents and combining them together, but our goal is for us to be able to put a long string of bases and exponents into the simplest terms. And what that means is, like, you know how we sometimes have stuff like 6x plus 5 plus 3x minus 2, and we can combine that to make 9x plus 3 by putting stuff that's like together. We're going to be doing the same kind of thing here, only this time it's going to have exponents, and that means we're going to have to be able to follow the rules. The first one that everyone forgets about, but it is actually fundamental, is the zero property, the zero power rule, where anything raised to the 0th power is 1. The only exception to this is 0 raised to the 0, which is undefined. This means that if you have a billion raised to the 0th power, that it is just 1. Now with adding exponents, you'll notice that it has 2x squared plus 3x squared equals 5x squared. That happens because both of these have x squares on it, and so it can be combined because it is the same base, x, and the same exponent. You'll see that if the bases do not match, like my xy and my xy, they can't be combined together. That also is a rule that if you have 2x squared plus 3x cubed, that those could not be combined as well. That it's just 2x squared plus 3x cubed because the bases and the exponents do not match. Okay, next, with subtracting exponents, the same rules apply where the bases have to match and the exponents have to match, but they can subtract the coefficients just like normal. With multiplying exponents, you actually don't need to worry about having the same exponent or the same coefficient or the same base. You'll notice that when you're multiplying exponents, you can multiply the coefficients. 2 times 3 equals 6. All right, and then you'll notice that I have 2 and 2 as my exponents here. And if I add the 2 plus the 2, I get 4, okay? That is going to be something that we are always able to do, where we multiply the coefficients like that and add the exponents. When you're multiplying exponents that have different bases, like 2x squared plus 3y squared, you can still multiply the coefficients. The 2 times the 3 is 6. But the x squared and the y squared can't be combined together any more than just being able to write them next to each other like that. That's where the 6x squared y squared came from, okay? Dividing exponents kind of works the same, where when you have 2x squared divided by 3x squared, you get 2 divided by 3 is 2/3. Instead of adding our exponents here, because we're dividing, we end up subtracting them. 2/3 x raised to the 2 minus 2, that turns into an x to the 0th power, which is a 1. That means that 1 times 2/3 just gives us 2/3. Because if you think about it, x raised to the 2 minus 2, that kind of cancels itself out, and that x can kind of just disappear. The same thing happens when you have your division, as you do when you have multiplication, where the bases are different and the exponents are different and all that stuff. If you have 2x squared divided by 3y squared, you can just make a fraction out of it like we did here. Put the top number, the first number on top and the second number on bottom. No big thing. Now, if you want to know something crazy, is this part down here at the bottom. You'll notice that we have 9 and 3 as our coefficients. 9 divided by 3 is 3, and that's where that 3 right there came from. When it says you can cancel out the variables, if you think really carefully about this, you have x to the 4 on top and x to the 2 on the bottom. And if you start looking at trying to cancel those things out, if you take 2 x's away from the top and 2 x's away from the bottom to start canceling them, then you run out of x's on the bottom before you run out of x's on the top, and you still have 2 x's left at the very top of the page, or the very top of the fraction. On the y's, you'll notice that there is 1 y on top and 3 y's on the bottom. And so as you start to cancel them out, you can take 1 y away from the top and also that 1 y away from the bottom until you run out of y's. When you take the 1 y away from the bottom, that leaves you with the y to the 2. And that's going to be where that y2 comes from, is because when you start canceling them out, it ends up leaving you with fewer y's. Let's do some examples here so you can see what this looks like. First and foremost, it says 2a squared times 4a to the 5th. This is going to be where we are going to be multiplying our exponents together. And so we come back over here, we check our rules for multiplying exponents. Multiply the coefficients, like literally multiply the coefficients is what it says to do. Okay, so let's go ahead and multiply those coefficients. This was a 2a times 4a. So if I take 2 times 4, I get 8. And then I take those a's and I go back to my notes, and y'all can read along with me, where it says that you are going to add the exponents together as long as the base is the same. So let's go ahead and do this. 2 times 4 is 8a. 2 plus 5 is 7. So it's 8a to the 7th power. Let's go to the one next to it. 5 over 2, 5 divided by 2 cannot be simplified, so it's going to stay as 5 over 2. We're going to handle this just by looking at the coefficients at the front first before we look at the variables, and we'll just go at the variables one at a time. We can start canceling out our b's. You'll notice that on top there are 6 b's, and then on the bottom there are 8 b's. If you cancel 6 b's out of the top and the bottom, that'll leave you with 2 b's on the bottom. So we're going to go b squared on the bottom. And you'll notice that there is a y over here. That tells me that there is just a y here as well. 5y over 2b squared is going to be what this is simplified. We can do the same kind of thing with the one on the right side where we are multiplying the coefficients. And again, the coefficients are these constants in the front. 5 times 3 is 15, times 4 is 60. So we're going to have the number 60 at the very beginning. Then I'm going to be looking at the f and the f. F has how many variables or how many exponents? Honestly, something I didn't mention to you, but it's interesting to think about, is there's an invisible 1 up there. This is an f to the 1. And so if I multiply the f to the 1 times f to the 5, I'm going to get f to the 6 power. And then, of course, at the end, I have that r, and I don't have any other r's, so I just put the r here. I go to the far bottom left and I talk about the 6 over 4. If I think really carefully about it, 6 over 4 can reduce. That is going to be 3 over 2. So I know I got a fraction here. I'm going to start canceling stuff out like these y's. Notice I have 5 y's on top and 2 y's on bottom. Think really carefully about it. If I wanted to cancel them out, which one would run out first, the top or the bottom? The bottom would. There's only 2 of those y's on the bottom. So if I cancel out those 2 y's on the bottom and 2 of the y's on top, I still have some y's on top. How many of them? Well, if I'm taking 2 of those y's away, I got 3 of them left up here. And if I look at those z's with 3 on bottom and 3 on top, those are going to end up canceling each other out like perfectly. Like, take away 3 again, they're gone. I'm actually out of z's. This is the answer I get here. 3y to the third power over 2, and that's it. Now, I got more multiplication going on over here on the next one, all right? Once again, I'm going to start by looking at my coefficients, the numbers that are in front, 3, 5, and 2. 3, 5, 2. Hang on a second. Hang on half a second here. You see, those are being added. Those are being added. I know it's easy to get in the habit of thinking, oh, we're just going to be multiplying. We might miss something. Pay attention to those symbols. We have to go back and check based on our adding. Is the coefficient different? It doesn't matter. Is the variable different? That does matter. They're both x as the base. The exponent also has to match. If it doesn't match, it's no good. Let's go ahead and start adding the stuff together then. 3x to the 4 plus 5x to the 4. The 3 plus the 5 makes 8. And since x to the 4 is the same on both of them, it stays as x to the 4. That gets multiplied by 2xy to the third power. Now that we're at this point, we can start combining some stuff together, okay? The stuff we can combine together is going to be when we multiply the 8 times the 2, which happens to be 16. I can start combining my x's. 1x times another 4 x's gives me, well, law of exponents when I'm adding. X with the 1 plus 4 is 5, so x raised to the 5th power. Last but not least, the y. There's only one y to the 3rd, and so I can actually just write the y to the 3rd here, and that is going to be my answer for this one. Now, I am out of room, so I have to erase this in order to be able to solve stuff, be able to have a little more room. This one is going to take a little more time. We do have to take it in individual steps in order to make sure that we are doing this correctly. 3 over 9, that is going to reduce to give me 1 over 3. I can start combining my a's by canceling them. If I start canceling out my a's, and I'm going to cancel them out because I'm dividing, I have 5 of them on the bottom and 7 of them on top. That means that I have more on top, which means I'm going to have some a's left over. 2 of them to be exact, because if I cancel 5 out of the top and 5 out of the bottom, that leaves me with 2 left on top. Then I can check the j's. With the j, again, canceling it. I'm looking at it and I see that, oh, I have a... Hang on a second, I'm going to fix the colors so we can see where all this stuff comes from. I apologize very much. All right. So 1/3. Let's go ahead and do it in red with the a's to the 5 and a's to the 7. Give me a to the 2 on top. And then I go back and I check my j's. J to the 2, j to the 4. I cancel those out. I have more j's on bottom, so I'm going to have j to the 2 on bottom, because if I cancel 2 of them, 4 take away 2 is 2. That is going to be where that part comes from, the j to the 2 on the bottom. From there, based on my thing I have to multiply here, I have to multiply now 6 times 1/3. What is 1/3 of 6? That is 2. A on top. When I'm multiplying like this, and this goes over 1. When I multiply a to the 3 and a to the 2, those get multiplied across the top. Those literally say, what is a to the 2 times a to the 3? And I say, I still have a here. It's a to the 5th because I'm adding those together. The j to the 2 on the bottom is going to look like if it was j to the 5 over j to the 2. And you'll notice that if you cancel those out, you have more j's on top. That means that you have 5 over 2, so I'm canceling 2, 3 j's left, j to the 3rd power. So it should be 2, a to the 5, j to the 3. Now I know you're like, but sir, why are we canceling these out? It doesn't matter. Why isn't it just given to us simple to begin with? And that's because when you're adding together or multiplying exponents, when you're trying to scale 3D shapes, it is going to use these properties, and so you have to be able to recognize where they come from and where to use each of these steps. I know that when you're working on calculus level stuff that you're going to end up getting multiple squares left over. These are only 3 of the exponent properties that we're going to go over. You're going to be doing more tomorrow. All right? I'd like you to go ahead and begin working on your worksheets. You got this. Answer 2 or 3 of them. I will come back and I will check.